Hi, Buck. Good morning for me, and it's about midday your time, I think. Yeah,
Yeah, 12:30 here. Just got through with lunch, nice potato soup and a little sourdough bread.
nice. Yeah, one of my favorite parts is I think pretty much every time I do a live stream here, it's there. I've had every other time zone practically on
Yeah. Yeah.
the other half of the camera. So,
Yeah, yeah,
thanks for
yeah.
coming on for your first time for
Yeah,
this.
it's great to be here.
Absolutely. Yeah, it's I think certainly a topic that will be a lot of fun today. But we've I think cross paths and definitely had shared social networks and professional networks for a while now. So
Yeah.
it's
Yeah.
I'm glad I was finally able to rein you in and get you on, and
Oh, that's
I
good.
think
Yeah, no,
have a
I'm
very
thrilled to be
fun,
here.
playful session today. Yeah.
Yeah, awesome. Awesome. Yeah. For folks that don't know me, I'm Buck Woody. I work at Microsoft. I'm a data scientist. I'm what they call an applied data scientist. So I'm less involved in the mathy things, although we do that too, but less involved in the mathy things, more in the actually making it work for someone.
The practical data
Yeah.
scientist. Yeah.
Yeah. Yeah. Yeah, the day-to-day
It's
where it hits the ground.
exactly like my brother's an economist, and he's not an applied economist, but he has a similar joke on the difference between theoretical economics and applied economics, the practicality of either one of the two.
I heard one time in theory there's no difference between a practice and theory, but in practice there is. So yeah.
I like that one. That's pretty good. Um, but I think one interesting spot to start with is you mentioned a little bit about what you do at least today, but
Mhm.
what led you to that spot? Like
Oh
where did you
wow.
come from? What got you inspired into what you're doing?
Yeah, we'll talk about that a little bit today. I actually started out in what is now sadly called good old-fashioned AI, the late 70s, and I'll talk about some of those methods and so on that we used. We'll talk about AI winters and so on as we talk about that. But I started a long time ago, and I've just always been interested in data. To me, data is everything. In fact, I used to work at the University of Washington for a while as a teacher, and I put on my faculty page all computing is just rearranging data. So every game or anything else you've ever played, anything you've ever done, it's just moving data around and putting it, making it the word red into the color red or whatever it happens to be. So it's always been a lifelong fascination for me in this. And now we're up to the world of generative AI.
The what like thinking of just rearranging data, one of my favorite infographics that's also related to or better said, to use Lego as an analogy, and it's show
Yeah,
like
yeah,
it's a bucket of just Legos, completely unorganized, and then you take those first, and I think it sorted them by type, and then it was type and color, and then they also rearranged it, and by the end of it, you got a chart,
right.
that was like and all of that, but like that's essentially what we do with
That's what we
and
do.
I really
Yep.
like that practical analogy to get to like
Yeah,
analytics and what Power BI was, but using
absolutely.
Lego bricks, yeah.
Yeah, when I was a DBA, a database administrator, I used to call myself a data janitor because I've pretty much just unplugging pipes all day. So
Oh, glorified plumber is a term I've used more than
yeah,
once. Like it's a very highly paid plumber.
yeah,
But
absolutely.
it's what's the analogy from? I think it was one other anecdote, and we can pop into the topic. But it was, I think, Theodore Roosevelt. It was some little like quip or story, and I don't actually know if it's true. But the years ago, there was the boiler in the White House was having an issue, so somebody came over and kind of looked at it for a few seconds, asked a couple questions, like knocked, drew a little X, took like 5 minutes, and they're like, "Oh, it'll be $500." And like, why on earth am I about to pay you $500? Like, well, it was $1 to draw the X, $499 to know where to draw the X.
That's right. Yeah, yeah,
Yeah,
that's very true. That's very true.
exactly.
Yeah,
Because it's not always time and materials. Sometimes it's the knowledge that comes behind the action,
that's
even
right.
if it
That's
takes a
right.
quick
And
second. Yeah.
and hopefully by the end of today, you'll have a little bit more on this.
Exactly. But coming, reining it in and thinking about what we'll be talking about today, AI has been a topic that's been pretty big over the last year. It's
Hmm.
obviously evolving pretty rapidly. The one thing that I thought was kind of mind blowing that came out recently was the Sora that does the little short
Yeah,
videos on like
yeah.
generations, and some of the stuff that it animates is mind blowing on its physics approximations for some of those. But like we're obviously progressing very rapidly with the tech. Every month, new stuff is coming out mostly. Sometimes ChatGPT is getting a bit worse in certain things, but overall progressions forward. But on the idea of generative AI and some
Hmm.
of the stuff we'll be talking about today, uh, What's some of the ideas of the topics we'll be getting into?
Yeah, I think, I've got some slides. If you want me to, I can pop over to those. You want to take a look?
Yeah,
Let me just,
absolutely. Let's do
let me
that.
just open this up, and here we are. Okay. Um, I don't know if you can see this or not.
Hmm.
The introduction of AI here.
Yeah.
So artificial intelligence actually kind of an umbrella term, if you think about it. And it starts back in 1956. And basically, what is AI? So I'll explain that a little bit more in just a bit. But it basically says a machine, a thing that does numbers, can do things that human behavior. I hesitate to use the word thought, but we'll talk about more about what that means. It's way back in 1956, and then what we can do, if you want, I can talk a little bit more about machine learning. All these dates, by the way, are semi-approximate. Things are always on a spectrum. But we had this machine learning, and what this does, machine learning, which we can talk about, and you put all this on your resume when you're done, Reed. Because I know you're looking for work, right? You've got what, two companies, and so. But anyway, you can put this on your resume. So machine learning is just using mathematical formulas to act over data rather than programming. And basically, you're just improving a prediction or a classification. Those are the two things that we do. And from there, we went to something called deep learning, which is using sort of layers of these algorithms to train that same model. We'll talk about what that means. And that creates a prediction or classification. And then, of course, now we have generative AI. And generative AI basically creates new stuff, generative. So it uses the stuff above it, the deep learning, the machine learning, and the old AI, and it can make new things to do that. So why don't we jump in?
Absolutely.
Okay. All right. So way back, this is the Wayback Machine. In 1956, there was a guy that said, it was as part of Dartmouth College in Dartmouth, that said, you know what, people are so predictable that you could probably write a program that would do what a person does. He said it a little better, but that's the general idea. That was way back in 1956. And so right away, because they're like, wow, people do these things and they do the same way all the time. So it's really kind of an easy thing to do. So let's figure out some ways that we can write those programs. And the first thing we did was we used something called symbolic development. And symbolic development used things like logic. If it's raining, someone will grab an umbrella. So I can now predict when someone's going to grab an umbrella. Not really a prediction, is it? It's more just cause and effect and so on. So we just used logic. Well, that was a little brittle because it didn't always work that way. So then these things came about of these math systems called simulation, some of them called fuzzy systems and so on. A lot of these started developing around an electronics era where we were doing switches and so on. Because remember, this is right after the war. World War II. I have to specify that. I'm sorry, that's sad, but that's the way it was. Then in the late 70s, when I sort of came along into this field, we had these things called expert systems. And that's basically where I ask an expert, how do you do your job? And they tell me that. And I basically, this is terrible to say it this way because it's a little bit more complicated, but it's sort of if then else trees. Basically, if your arm hurts and you raise it like this, then you might have a broken arm, that kind of thing. So we began to make it more complicated. We had programs we wrote in. Prolog was one that I used, and a few others to do these good old fashioned AI. And you had some things that were like evolutionary computing. These were the beginning of our systems that could learn or change themselves and adapt. Then things were sort of overpromised into the 70s. The Time magazine had the robot is coming to take your job and sound familiar, all that kind of stuff.
Yeah.
And of course, it didn't happen. This stuff was very brittle. You cannot make a logic system or an expert system. They used to call it decision support system, DSS. You can't make one of those complicated enough with that many if-then statements. It just doesn't. You can see, Reed. I mean, I'm sure it would just break down, right? I mean, you just can't.
Yeah.
You can't keep up. So the next sort of interesting thing was we went way back to statistics. Some of the statistics go back to the 1800s. A friend of mine named Anna Hoffman and I did a series called Something Old, Something New. And I would take an old stats formula and talk about where it came from. And she would then use it in Python and machine learning. It was a really fun system. But at any rate, statistical methods started giving us things like inference. And inference is pretty straightforward. You look at what has happened and you infer what will happen. And there's all kinds of things you can do to do that. We'll see a few of those. And along the way came things like information theory, which was actually done in physics. to model some physical things to transfer information or electronics from one place to the other. And that actually had applications in computing. And then you get into some really cool statistics, Markov models and Bayesian decision theory. And Bayesian decision theory is interesting because it can take a prior. It can say, oh, I know what came before, and I'll modify what I'm going to predict based on that. So this is the old days. Once again, promised a lot, fell into disrepair, AI winter. Oh, it's not real. It's not going to happen, and so on. But a strange thing happened along the way. Databases started coming into play. And when databases started coming into play, you got larger and larger sets of data. And you could do these systems that would sort of take a lot of data, let you run an algorithm over it, and it
Mm-hmm.
would begin to churn out some information, right? And so this we called machine learning. Now, I want to be really careful about the word learning. If we say learning is a way of improving a outcome of a function based on previous information, if you want to call that learning, we'll call that learning. That's okay. But we did have some families of algorithms that tended to work pretty well. And one that works really well that we use a lot, I still use it all the time. And by the way, none of these things makes the other thing go away. Like the stuff that we had from stats is
True.
still used here. One of those is a regression. And there's lots of kinds of regression. There's linear regression, which is a straight line, logistic regression, which is not a straight line, and so on. But basically, I say it was hot yesterday in Florida. It's a little hotter today. I'm going to predict that by July, it'll be much hotter, right? That's a line. Do you remember f of x equals y, or remember all that? The
Yeah.
stuff y equals mx plus b, the slope of the line. Remember that? Did I
Mm-hmm.
just send you back to high school? Sorry. Um, you get the slope and the intercept. You know what I'm talking about, right? And then you
Yeah,
would have to like
exactly.
put okay, what's x when you get to y equals 20, and you had to write that down. Remember that?
Mm-hmm.
That's what you're doing. It's a version of that. So if I have a bunch of data, and by the way, the data is just columns, but we got to rename everything so it sounds better. So the columns of data, like for instance, I'm wearing a black jacket and a black shirt and clear glasses, and I have a beard and so on. Those are things we call features. Features, and these just mean things about the thing we're trying to predict. And then what I want to predict, like let's say the temperature, the humidity, the temperature, the date, and so on would be features of making a prediction about the temperature. So I'd get a bunch of temperatures I recorded over many, 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 many years. I would have all the features. If it's July and it's Florida and the humidity is high, it's going to be hot, right? I can predict the hot part because I've seen the other data. So I train an algorithm, meaning I run a lot of that data through there, and it gets better and better through various ways to figure out how do I make that prediction. Now, it's a prediction, so it's always going to be iffy, but it's a prediction, right? So that's basically one of the algorithms. We use this one a lot. It's very simple, very effective, works really well. Another one is called anomaly. And what this is it odd? And when I teach class, I always say, is anything odd about that picture? And people begin to answer, well, this is odd. That one's a mechanical pencil, and that one's a colored pencil, and so on and so on. I'm like, wait a minute, I haven't told you what the data represents yet. You're telling me the features. I haven't told you what I want to know. Now, if I say, if you open my desk drawer and you saw these in there, would that be odd? You'd be no. But if I make mechanical pencils, and this is in one of our boxes we're shipping to a customer, we've got some oddities there, right? So the question drives everything.
Mm-hmm.
But anomalies
True.
are hard. Now, we use this for cancer detection. Anomalies we use for a lot of stuff. The problem with anomalies is there aren't a lot of them. They're anomalies. So it's hard for the algorithm to figure out, oh, that's weird. So because it sees so many things that aren't weird, it just goes, yeah, that's probably just a fluke. I'm not worried about it. We can't make it look at it. It's really kind of hard to find. So these are interesting algorithms. Another one that is super common is something called classification. And this is just which category is this? And there's really just two types. There's binary classification. It's this or it isn't this. And then there's multi classification. But really in the multi, it's just a lot of binaries. It's a bird, it's a bike, it's a tool, right? If it's not a bird, then maybe it's a bike. If it's not a bike or a bird, maybe it's a tool. If it's not a tool, it's not one of those things. So we can classify, but these are really useful. So if we want to classify our high earners, somebody who makes a lot of money. We want to market towards them or whatever it happens to be. We want to make our line better. We want to classify parts that are good versus machines that are not making good parts and so on. That's a good one too. You've also got the reinforcement learning. And this is like your Roomba that wanders around the room and hits the wall, and after a while it doesn't hit the wall anymore because it's learned. That's called reinforcement learning. That's a kind of machine learning. I put a
Hmm.
green wire and a red wire. You ever notice in all the bad guy movies, they always say cut the red wire or something?
Or it's
Um,
like, yeah, they cut the red, not the blue, or it's some
and I'm
color.
like,
Yeah.
I would just make all the wires red, and then I don't know, I don't know. Anyway, red and green. And then the final one is a little different. All the things we've been talking about right now are called supervised. Supervised, and what that means is I have examples of the answer from before. I have all the temperature. I have all the things that were normal, so I can do the oddity. I have all the classifications of birds. I've got some examples of those, so it could figure those things out and then apply it to new information. But sometimes I don't know the answer. For instance, maybe I just want to put people in a group, and this group we call this, by the way, a clustering algorithm, or sometimes a recommender. People who like this movie like this movie. So we give it a number of centers, centroids they're called in certain algorithms, and it basically will collect through various math ways to say this is the best way to divide this group of information into three centroids. So for us, that would be very hard. If we walked into a room and I said, divide this room into three groups perfectly, and they've got to be the most alike. We'd be like, well,
Mm-hmm.
there's more of this gender than this gender, or more of this hair color, or more of this weight, or whatever it is. We have a hard time doing that, but math can do it very well. A lot of times, support vector machines and things like that can do that quite well. So anyway, these are some of the families of machine learning. So Reed, you can now put this on your resume that you know machine learning.
Yeah, well, and I know like what machine learning is good at.
Yeah, yeah, there you go. And we have
Yeah.
to pick you've hit it on the head, is you start with the question, which is the hardest thing to do, and then you figure out which of these algorithms would best answer that question given the data you have, and sometimes you don't have the right data. So the machine learning still used today, still very useful. It's in a lot of things we use, your watches, your phones, cameras, things like that, very useful. But as you pointed out, it's a little brittle in that it does need a specific pattern to find things. So we needed to go to the next sort of level. And so the next level we do is something called deep learning. Now, it's the same exact thing, meaning it's got those same algorithms, families of algorithms, but it's now composed of these things called neurons. And I don't like the wording in here because it starts making you think that it works like the brain, and our brain is way more complicated than that. But basically,
Yeah.
deep learning is just a subfield of machine learning, and it just uses these things called artificial neural networks, or ANNs, to again learn from data. And basically, we take the data and if you can think of data as sort of a Rubik's cube, you take that cube and you take a slice off and you put it down and another slice off, and now you've got three slices. Then you unroll the slices where they're long like this. That makes something called in math a tensor. And in the tensor, you can send those bits of data. And again, these are features that we care about. And we can send those features in, a lot more of them now, a lot more parameters than we might use in machine learning. We can send a lot more features into these neurons that do a specific thing. And then these neurons, which is just math, will, let me show you one. It's basically just a math that uses something called an activation function. This one I think is a sigmoid, it looks like. So the sigmoid is a particular math thing that says, I'm going to do some math, and I'm going to decide if the next layer, the next set of algorithms, needs to care about this. And that's called an activation function. Now, sometimes it gets it wrong. So it can actually check itself, and it can do something called back propagation and say that wasn't right. And if you'll notice, there's these things called weights. It can actually just say, add a 3 to that and see if it gets any better. I know that sounds weird, but that's what it does. And then it didn't. Oh, try 2. Oh, it did? That helped? 2 then. Let's add a 2 to that. And that's what it does. And so it sends it on. Now, there's not just 3 layers like this. The first one, by the way, is the input layer. Then there's ones in the middle that are called hidden layers because you don't know what they're doing. The algorithm, the libraries that do this stuff, the Python and R libraries and so on that do this, they handle that for you. So basically, there's lots of these, like thousands of these things. And what they can do is take like a bunch of pictures of faces, and they can send them in, and maybe one layer does edges and one layer does combinations of edges and one layer does contrast and another does color and so on. And then at the end, it knows I'm anthropomorphizing again, but the algorithm has been trained to recognize the picture of a face, and it goes, yeah, that's Reed, because it can do that. And because it can take in so many parameters, maybe Reed looks like this or like this or like this, but it can kind of figure that out. So that's deep learning.
So a question just from someone in the audience is they wanted just to know how much more complicated can a brain actually be, and why can't this be as complicated as a brain? I dropped them one link just to say that there's approximately 100 trillion neural pathways that the brain can take at any.
Well, there's that.
Yeah. Among a few others.
Yeah, we use neurotransmitters. We don't have a single kind of neuron talking to another neuron. We have dendrites. It's wildly, your brain is an absolute marvel, which I just boggles my mind that people like politicians or whatever have brains. It's kind of amazing. They're really complicated, amazing, stunningly adaptable. They're very plastic. You have half the neurons, I think. This may be incorrect, so don't quote me on it. But you have a lot less neurons by the time you're 7 years old than you had when you were little, because you've now learned to see and do a language, and so stuff just drops off, and you can build more, and other parts of the brain can take over. You could never do that with just pure math.
It's true. Like somebody loses half their brain and then they remap everything to the other half.
Exactly. Oh, that happens all the time.
From surgery.
Happens all the time. Yep. And that interconnection is huge. And this neural network is connected, but not nearly as connected as the brain. The brain is connected to each part of itself and each area, and areas we're not even sure how they work and so on. So that's the other thing. We don't know how the brain works. We kind of know how these work. That's a great question. Any more?
There's a couple of other ones that I think I'll save for the Q&A. That was one that was topical for what was presented, but I think I'll just close off that conversation to say as far as I'm aware, the human brain specifically is just sometimes the most complicated single thing that has ever been observed in the universe, as far as the complexities that are involved in its design.
Yeah, says the brain.
Well, says the brain. Well, yeah, like that we've currently observed. So far, I'm sure there is something else in the universe more complicated than it, but
the brain is the only part of the body that's aware of itself, right, and talks about itself. The brain is the most important organ in the body, and I'm like, yeah, it's the only one that talks. So how do we know, right? Yeah. So anyway, these families, by the way, like you saw the families of algorithms before, they call these a deep learning framework. Mm-hmm. So that's a library that you use. TensorFlow, PyTorch, Keras, MXNet. There's a whole bunch of these, and there's more coming sort of all the time. So it's really kind of interesting. And in machine learning, does not scale. You can't have infinite data. It actually reaches a point at which more data is not helping and can slow things down. In large part, deep learning, the more data you throw at it, the better it gets. So it improves. True. So fun, just unbelievably amazing stuff. Again, why I like this. All right. So let's see, Reed, you're now an expert in AI, good old fashioned AI. We trained you in machine learning, and you're now an expert in deep learning. Let's take you to the next level here. Let's take you to NLP, natural language processing, and then we'll do generative pre-trained transformers, or GPT, and we'll talk about LLMs and a few other things. So we'll talk about how these work. Now, this does start getting a little more complicated, but it's building. It's still just building on what we already did. So these are going to be deep networks. These networks that we're looking at are going to be deep neural networks that we're working with. All right, let's talk about natural language processing here. And basically, this is super exciting. And the reason it's exciting is most AI stuff is either visual or it's sound or colors, things like that. We don't really think like that. We think in objects, which we've represented in our mind as a word. So when I say the word read, I know what I've got a picture of you in my head, but I use the word read to think about you. So now that we take AI, we take these deep learning and machine learning, and we start pointing that at words, it begins to seem magical. And it is magical, but it's not. It's the same thing that we've been doing. It's just a little different. All right, let's walk down how it works, and then I'll show you something that's really important for us to see, and then we'll sort of go from there. All right. So the first thing we do when we get a corpus, and again, we have to rename everything because that way data scientists can make a lot more money. We don't say text, we say corpus, and that way it's Latin, so obviously we should be paid more. So that's basically the way that works. And there are libraries, again, software libraries that will do all of these things. So the first thing we might do is look over a bunch of text. And when I say a bunch, when we get to the next section, you'll see that it's 21 years worth. But let's just say we take a document, just a big document that has a lot of words in it, and we swallow that into a library. And the first thing we do is we normalize the characters. So we get rid of the weird characters and we get rid of things that are bolded or underlined. Who cares? We get rid of italicized words and things. We just make everything, we just normalize everything to where it's swallowable by the next layer. And then we do something called tokenizing, which is kind of interesting. When we begin to tokenize the words, we're sort of breaking the word down a little bit so that it can be stored as a number, because computers don't know words, they just know numbers. And so we get everything to a token. So now the words are numbers. Now we start stemming and lemmatizing, and these are grammar things. So if I say running, you can get rid of the gerund, the ing, and you can just say run, and that the computer can figure out, okay, I understand, I don't need active tense and passive tense and all, it doesn't matter. So it gets rid of that. And then we get rid of any stop words, words that don't do anything, periods, things like that, that don't really help us with the sentence at all. So that's what the first set is called, pre-processing or cleaning the data. So we do that. And the next part is we still need those features. We still need to predict something. And what we're going to predict this time is words and maybe groups of words. So if we want to predict words, we need to turn those into numbers. And then if we want to predict how those words relate to each other, now we get into a vector. Can I show you a cool vector thing?
Yeah, please, absolutely.
Okay. So what I've got here, this is a really cool place. It's called projector.tensorflow.org. That's not associated with Microsoft at all. But basically, this is a bunch of words that have been read in. It's from a standard data set. You can load your own in. You can load a document in. And then what you can do is you can say, okay, vectorize those words. And what it's going to do is this, Reed. It's going to take those numbers. It's going to see where they are in the sentence. And based on the kind of word it is, it will know direct object, it'll know verb, and so on. And it can embed a number, an embedding, that is a bunch of numbers. It's actually a long number that's a bunch of numbers. And it puts them together, and now they are in vector space. So I broke your mind earlier with y equals mx plus b. Do you remember you plot the x, you plot the y, and do you remember plotting the z? Remember that?
Yeah, I mean, X, Y, Z, right?
Yeah. So you got the x and the y and the z, and you've got a place in space. So assume a word is now a place in space. And by the way, that z is a dimension. We would have lots of dimensions. You can see some words scrolling around here. And let me put one in here. Let me just put the word queen. Queen. So in this text, looks like they found 3 words that are queens. And you can now see that Queen and Elizabeth from the text that was written, you can see them floating by there. I'm pointing to the screen. Hopefully you see that. You can see they're very close. There's not a lot of space between them. And by the way, there are various ways to get that space. There's all kinds of cosines and things. Again, if you remember your X, Y's, and Z's, there's
cool.
ways to do these. But you can see how closely a king and a queen are together as well in our corpus, in our body of language, which is just a number. But now when I say take a noun and a verb and another noun, put them together, it can say the king knows the queen. And that makes sense to us, but it's not real. It's not real. That isn't real. It's just putting those words in a vector space that it gets. That's all it does, okay? So now it can, stay with me here, it can understand text. It doesn't really understand anything. It's just doing math. But what I can do now that I know those things, I can begin to use those same models, and I've got a split test and train. That's where I do know the answer. and I don't know the answer, or I do know the answer, but I'm not showing it to you yet. So I train and I say, how good can you predict these words? And if it's not good, I do it again and so on. And this is called fitting. I fit the model to the data. And then I go see, how did it do? When we say perform in machine learning or in data science, we don't mean how fast it is. We call that speed. I know we use big words for regular things, and we use regular words for regular things. So we call that just speed. When we say performance, we mean how well is it doing? And we've got numbers. There's actually some formula that we can use to say, here's how this performs. There's something called a confusion matrix and an area under the curve and a bunch of other stuff. Anyway, we can tell sort of how that works. Then when we're done, we can create a deployment. Now, what we've done at the end is we've trained an algorithm. We've trained a formula, kind of like an Excel formula. And now you can say, average these three numbers, and it gives you an average. Well, in this case, the formula says what word would come, after this one, and it will say, or what does this say to me? Oh, it's telling you about a king and a queen. So I can now do all kinds of reduction things and so on. Okay. And this is huge. This is amazing. This is your phone being able for you to talk to it, takes the sound waves, turns them into analysis of words, takes the words, turns that into an NLP, goes down, and it types the words when you type them. We take it for granted now, but it's stunning. This is magic. It's a tool, just a tool.
Yeah.
All right. So now we're ready for the big boy. So I need you, Reed, if you don't mind, need you to make sure you look at these three graphics, and I'll need you to memorize, especially whether you're going to use a transformer or a BERT.
This will be on the test, right?
This is on the test, whether we're going to use a BERT or a GPT to do our transformer architecture. All right. So you're not meant to understand this, please. You're definitely not meant to understand this. This does the same thing. Once again, it's a kind of NLP with a little bit of a twist. There's a thing in the middle that you can see that has you can see it pretty well on the transformer encoder in the BERT architecture. You can see that pretty well in this one. GPT is just another one. You can see it's got transformer blocks here. And basically what's happening is this. First, it understands the word and the sentence and the vectors and all that stuff. And then what it can do is you can say something, type, or do your voice, and it turns it into typing. And you say, I would like for you to generate some more of that kind of text. So think about this for a minute. So it knows what a story is, and it knows what a picnic is, and it knows what a king is, and it knows what a queen is. And you can say, write me a story about a king and a queen on a picnic. And it's swallowing all that and understanding it, and then turning around and giving it back to you. Now, it does some interesting things. It doesn't do that exactly, because if it did, you get the same story every time. So it adds a little, like, okay, I know what a story is. It has a beginning and an end. Some stories are good, some are bad, and so on. So it kind of changes it. Every time you ask it, it's not very deterministic on purpose. But it did some interesting things. When we can do this, this is called a foundation model. And what it means is, it's not like our older algorithms that could predict the weather, and that's all they do. Or it could tell, cut the red wire, or it could tell, don't run into the wall with the Roomba. It actually is a tad more. A foundation model is something that can do more than one thing. And so by inventing these generative pre-trained transformers, so it generates, it's pre-trained, and it does this transformation mechanism, GPT, generative pre-trained transformers, it suddenly can do these things. It can answer a question. It can create a story. It can generate code, because it's seen tons of code. So it's like, make me some code that does this thing. Okay, let me look around. Oh, here's one. If I put these together, it'll probably work. Does it work every time? No. But it does it can do summarization. What is War and Peace about? One of the biggest books ever written. What is War and Peace about? And it comes back, it's about Russia. Right? So it can summarize things for you, and it can generate new things, not just text, because it was also trained on graphics. So it can start doing graphics. And then you saw the idea that I can take some text in Sora, create a cartoon of a mouse that runs after some cheese, and it says, I know what create is, I know what a cartoon is, I know what a mouse is, and I know what cheese, and I know what run is. Let me go get a bunch of pictures, put those together, and make them into a movie for you. And it does. It's just absolutely stunning. but it did something even weirder, Reed, something we didn't think about at all. Um, and when I say we, the data science community, um, it did some things where as the models got bigger, and what I mean is the algorithms are more complicated and it takes in what we call parameters, more parameters. As it got bigger, it was doing things we didn't think it could do. For instance, translating. We didn't teach it to
Yeah.
translate. We didn't tell it to translate, but we did make a vector space for king and queen in German. I don't know what that is. I'm an American. I only speak one language. So, and it knows what the king and queen in French is. It knows those things. And so when I tell it, tell me a story about a king and a queen on a picnic in French, it goes, okay. And it does it. And we're like, oh, we didn't, we didn't tell it to do that. So this becomes kind of interesting because there's some things we didn't know that it could kind of do. And Reed, I want to, before we go into sort of how do you use
Hmm.
this, because I'm sure that's a question you have. I want to talk to you about what have you seen people say about AI when you say, oh, you should look at doing GPT for your company. What are the couple of the things you hear?
I mean, there's definitely a lot of people who, this, with every push of AI, is the like, what jobs is this going to eliminate? But I think for practicality, and uh, I'm certainly for mine, I recommended the like it's a time saver for a lot of. I use it on a regular basis to simply just I present a lot, so I have to do titles and abstracts, and
Right.
I can come up with 60-70% of something like, and I just give it the doc and do you have any other ideas of like what else I could maybe talk about? Like, and then it will give me a couple bullet points. Like,
Yeah.
actually, yeah, that would be a great topic I could also
Yeah.
discuss. And I'll go, yeah. So it's honestly, it works really well as something to bounce ideas off of or to finish something that you partially worked on that requires text or language or anything.
Right.
So that's what I see people using this is it's a, in a lot of ways, kind of a glorified assistant
Yeah.
or
Yeah.
being able to round robin an idea and bounce it off a couple of times to get you to think about something and have more epiphanies yourself.
Yeah. I think you've nailed it. When I go talk to people, they're like, well, it's like a calculator. It's not that big a deal. And then other people are like, oh, it's Jarvis from the Marvel movies. And I'm like, well, okay,
Nowhere near there.
it's not, yeah, we're not, okay, no. Will we get there? I don't know. Great question. That's another topic. We'll have another show about that one. But let's talk about something called Midjourney. Midjourney was one of the early attempts at successful attempts at creating graphics, and so they gave it something called a prompt, which is this is what I want, and you have to. There's a way to talk to the computer. I always like to say it's like talking to somebody that doesn't speak your language, and you're trying to get them to help you with a problem, and you're thinking, how do I put this so this person understands what I need, right? So you have to do that. So they told the prompt in Midjourney, and I think this was in 2022, early 2022. Draw a picture of a young blonde girl in a field of flowers, and so it drew that, and you can see it's
Yeah.
pretty good. I mean, I can't draw like that, but there's like an eye on her nose, and her
Yep.
head's not right, and I don't really see the flowers.
Hallucinations.
Yeah, well, it's just not that good. It's just not
Yeah.
that good. So about a year later, a little bit more than a year, but not mostly a year more. This is with the same prompt what it did.
Mhm.
And if
Yeah,
you
it
if
gets to the point of like photorealism now. To the
I
like
mean,
there are some small tells, but it's harder and harder to tell other than it's too perfect.
yeah, yeah, and not only that, I mean, this is in a year.
Yeah.
No other technology has done this. I mean, to increase in the product, same prompt, by the way, just different models,
Yep.
same training data, just different models. And this is this is real. This is actually real. And we were talking earlier before we started, um, you know, is this stuff as AGI coming? I mean, does it matter if it looks this good to you? I mean, do you need, if you're doing a brochure or something now, do you need to go get an artist to draw you the picture of the girl? You don't anymore, right?
Well,
It's just
that's
incredible.
those are the two. I will say those are the two industries that will be hit the hardest. Is anybody that editors and or underwriters or not under the people who do any type of editing, typing, or helping with that, and or unfortunately creative artist industry is. But the one thing that I just found super fascinating on this is it's It's this is the it's an Ouroboros snake eating its own tail now, because the problem is all the AI generated images are now feeding back into the AI generated machines that are generating the images, so they're starting to become reductionistic of themselves because
Yeah.
they follow a certain pattern on how they do stuff, and the more content's generated from them, the more they're
Yep.
going to start looking like that because it's
Yeah.
so
That's
the
correct.
the
Yeah.
models are getting less creative, not more creative on their own image generations.
Yeah, it's the cloning paradox. You can't clone too many times, right? It's like making
Yeah,
a copy of a copy of a copy. After a while,
exactly.
the copy doesn't resemble it. So let's now
Yeah.
talk about, we've talked about what this stuff is. So you can put all that on
Mhm.
your resume, Read. Just put me down as a reference. Um, and then let's actually put it to work a little bit. So in Microsoft, and there's every company's got these, but I work at Microsoft, so these are the tools that I use. We have a tool called the AI Studio, which lets you get started with this stuff very quickly. We have pre-trained models, so you can just say, I need some stuff translated. I don't need all this GPT nonsense. I just need something translated. We can do that. I need to make sure that people, if I let people upload pictures to my company, they're not uploading something that could go get me in jail. And so we have that already. We need something that reads signs and creates text out of that. You don't need GPTs for that. We have all those. We call those pre-trained models. They're just done cognitive services. But we also have full Azure OpenAI, which is the OpenAI service that completely runs on Azure. And we'll talk about like what we do with your data and so on. Speaking of which, we do have the Azure OpenAI service, and it's got all these things. This is already old. So there's new stuff coming out all the time, but you can do a lot of things with this. So as you pointed out, if the and I'll give you a little diagram here at the very end. I'll give you a diagram of how I use generative AI every day, or AI every day in all my work. Now, of course, we've gone crazy at Microsoft with copilots, and we use these a lot. We call them copilots, by the way, because we don't believe that AI should be making decisions. We believe it should be helping you make decisions. So you're the pilot, it's the co-pilot, and can help you, just like you were describing. I've got an idea. Give me four more things I should probably talk about. You didn't tell it, create the idea and make a
True.
slide deck and present it for me, because we don't believe that's the right thing to do. But we're putting these all over our tools, Word documents, and so on. And they're real. If you'll learn to use them, they're real. They're stuff that can sort of help you out. The one that you're probably familiar with that I use a lot as well is basically GitHub Copilot, so that when I'm
Yep.
in code, I can begin to type. I can never remember like pivot statements. They always throw me for some reason. So I can just say, can you just pivot this for me? And it tells me what to do. Is it perfect? No, but it can get me started. So I use this a whole lot. I use this a whole lot. You could see it can take a comment and do stuff from it, or it can finish your typing. Oh, did you mean to use a thing here, and so on. And again, the jury is no longer out on whether developers should be using this. Of course they should. Trust but verify. But absolutely, developers should be using this code. Again, I do not just trust it blindly, but I do use it. So I'm a database guy, and so I'll talk a little bit about how we use the data. Now, of course, the data is in a database usually, so a lot of times these are sources or sinks for the data that AI is going to use. But SQL Server has something called machine learning services. So it's a relational database, SQL Server is, that you can install locally, and you can put it wherever. It goes on everything from tiny devices that run on, little Pi things or whatever, or it goes all the way up to the big main systems that we use. But you can use your Transact SQL, the dialect of SQL it uses, to get your data into the shape you want. You can use SQL Server Integration Services for data engineering. It works on the cloud, it works on every cloud, and so on. And it's a complete ecostructure, but it's got this thing called the Machine Learning Extensibility Framework. And what this
Okay.
is R or Python or Java or whatever, you can actually use whatever, sits alongside SQL Server, and they have a shared secure memory channel, so that you can tell SQL Server, I'd like to take this data, select it with a select statement, and I'd like to do this kind of Python or R or whatever work. And then I want you to give me the answer back in SQL Server. So it kind of passes it over. So those two servers sort of work together. I'll show you one I did, which I really like. And I'll give you this reference here down at the bottom. If you go down to aka.ms /SQL OpenAI, This is a notebook, a Jupyter notebook, which is just kind of a web page that can do things with something called a kernel. But the idea here is I've got the ability to take the AdventureWorks sample database, tell it, hey, I would like to generate some ad copy of exactly 2,000 letters. That's what I've paid for on the social media sites. I want exactly 2000 characters, and I want you to do some ad copy just given the name or a short description of my bicycle, and write that for me and then draw me a picture or whatever. And it will do that. And so you select the model number of the bicycle and the short description, and then you send that as the prompt to OpenAI using machine learning services, and then it comes back with here's your copy, and you stuff that in a cell inside your database, a row and a column, and then you can go back through it, read it, make sure you like it, and it's done the work for 0.04 cents that you would have paid a marketing person to do. So that is a thing you can do. Yeah. So it's kind of interesting when you look at how it works. It's kind of like this. Here's an R version of how that sort of works. So this is the potential that you can do with this, where I send the data over and then it does it in R and then sends it back. In this case, you could do Python sort of as well. Now we've got the OpenAI service, and you've got the ability to call it like I just said with all these different things. But then it gets really interesting. Azure SQL DB, which is our service that runs SQL Server, we don't let you run machine learning services on that because you need to get down to the hard drive to run R and Python. We're not going to let you do that. You can do it on a virtual machine. That's yours. But a shared service, we can't let you do that. So we thought, well, what are you going to do? So a friend of mine wrote a blog just like the one I wrote, doing the exact same thing, but he did it with Azure SQL DB. And what we did was we opened up REST, representational state transfer, so REST calls, APIs, into SQL Server. So now in SQL Server, I can make a REST call and get the result back. Well, I can take that same bicycle number and model description, send it off to the REST API, that is Open API, and I can get the result back and stuff it. And I can also do other things. I've got all kinds of things I can do. Azure Functions and application services, Logic Apps, Power BI. I can do all kinds of things right from with just one line of code. So this is, again, the possibilities of what you can do with this, even in a relational database, it's just absolutely stunning and scary.
Well, I like the idea you made one mention on that just kind of actually helped explain why you need a data gateway installed if you need to run Python or R in the service in Power BI.
Oh, sure.
As well, because like you mentioned, like there's certain access that those require that we don't want to grant permissions for security reasons in the cloud.
Right. Exactly. Yeah. That's why we use the REST calls here. That isn't the only danger. There's actually a lot. I'm kind of big on security, really important. Security is a big deal to me. So I wanted to kind of go through some of what we do. We start with sort of a secure foundation. You can read all this stuff. I've got all kind of links and stuff. By the way, I've got at the very end here, I've got a download of a PDF of all this with my notes view, where I have all of the links that I'm talking. When I say something like, oh, that's this, and you're like, wait a minute, I want to learn a lot more. I've got those in a download for you at the very end here. Nice. But basically, if you go out to azure.com and then you look up our security foundation for how we run a data center, it's a big deal. It's not just lip service. It's a big deal. It's a big deal. And I won't bore you with all the things you can do. Now, you can have a Volvo, which is a very safe car, and then you can take a Volvo and run it into a tree if you want to. So there's a shared responsibility. There's things that Volvo has to do to make their car safe, and there's things you have to do to drive safely. And we have exactly the same thing. As you're working on things, we've made it as secure as we can. But if you make the password and you have an app that's all it takes, that's not going to be very secure no matter what we do, right? It's not really going to help you. But in light of that, we do have a ton of stuff in security that we do to make this work well for you. We have everything you can imagine: information protection, network firewalls, security posture assessments, private connections, everything you can possibly imagine. And we even have co-pilots on top of security that are watching the security. So I just wanted to make sure you saw that we really are thinking about this. And then there are questions that come up. I get this all the time. So I just thought we would just take a look. The data that you do is not available to other customers. It's not available to OpenAI. We do not improve the model with your data. We don't do that. We don't improve any of our stuff with it. We don't improve any third-party stuff with it. It's not used outside of Azure at all. And any fine-tuned models, this is where you take your own data and so on, and train your model to make it better. That's yours. We do not mess with that. And we do a layered approach and all those things. So this is really important to me that you know this. And the OpenAI service that we're running is not OpenAI. It's OpenAI on Microsoft Azure. So we run that, not OpenAI. They give us the software, we run it. They don't get to come in and take a look or whatever. So let's put a fine point on it here, and then we'll go to Q&A if you want. I'll give you some resources as well. The first thing I wanted to say was AI automates tasks, not jobs.
Yep.
AI automates tasks, not jobs. And by the way, automate is the most it can do in my mind. So what I do is this. I take the big things I do every day. I lay them out in a spreadsheet because the world runs on Excel. I lay them out in a spreadsheet, and in one place I have the task, the big task that I'm asked to do. Like you just put one, you've got to generate the errata or whatever for when you're doing a session. So you put that down, generate errata for my session, abstracts and whatever. And then you put on the right, how can this be augmented? How can this thing help me? And you put down, well, I could ask it to do these things, and here's the prompt I use. How could it automate that? Well, I wouldn't. So I'd stop there. And then the next column I put is the cost. Like, how long does that take? And how much does it cost? If it takes me 3 minutes to do it, and it takes GPT a minute to do it, and it's $1, I'll just do the 3 minutes. My time is not worth that. Okay, so I don't do that. But if it does it in 30 minutes, I can do a task that would take me all day normally. I'm absolutely using that, even if I pay for it, right?
True.
So yeah, I mean, and that's what I do. I go down, augmentation, automation, and the cost. And then when I'm done, that's what I do. So I do it every day, all day long, to do things. I've got some resources for you here. First is tinyurl.com, BWoodyGPT. That's this deck. So you've got all that, and look in I printed out the slides view, but I printed out the notes view of the slides. So you've got absolutely tons of URLs to go learn a lot more, and they're curated. So there's a lot of them, but they're curated. The next one is Microsoft's AI. That's how you get to all our AI stuff. Really good place to start kind of plumbing around. Free training, free books, all kind of stuff in there. And then at the very end, I've got some presentations that have a lot of my notebooks and have a lot of
now that last one isn't linking because I was typing each one in just to put it into the chat, and the first two work, and I tried it with and without the HTTPS aka.ms/BW presentations.
Oh,
didn't seem to be currently working. It took me to Bing. It just took me to the Bing homepage for whatever reason. That's really weird. Like I literally typed that in on aka.ms.
It's working for me. I'm going to paste it here.
presentations.
Yeah, if you type
goes
that,
to Bing. What?
AKA.
I mean, let me try this on Chrome. And then, or if anybody in the chat has successfully typed that in. But yeah, for some reason, it kept taking me to the Bing homepage on Firefox.
I just do aka.ms/BW presentations, and it does come here. But I'll paste. That's just a short URL. I'll paste the long URL here.
There we go.
You found it.
It doesn't like Firefox. I typed the same thing into Chrome. It works. Yeah. On Firefox, it goes to the Bing homepage for whatever random reason.
I use Edge. By the way, one of the presentations while we're sitting here, I've got this one where I go through all of the old AI to the new ones. It's kind of fun. It's interesting. So it's got everything. There's my old expert system. This tells you you're going to die or whatever. This one does Bayesian decision theory. So if you want to play around, there's some cool things in here. You're welcome to. You can also see how I do my Windows updates and how I do set up my PowerShell environment and all that kind of stuff. So anyway, just some cool things there. So we'll go back to the slide in case someone wants to take a screenshot of that. And Bob's your uncle. Okay, you may be going through a VPN in Firefox that you're not going through in the others. Maybe
it could be, yeah.
Yeah.
I recently switched over to that because I know Chrome was did an announcement that they're changing things that may kill a lot of those like U
Yeah,
origin ad blockers and other stuff. Like,
yeah,
all
yeah,
right, no,
yeah.
I'm finally just gonna switch over to Firefox. Like
I've been using
it's
Edge. I
not,
really
yeah.
like it. I like, well, this is kind of funny. Let me go back to Edge here. One of the things I can do right here is this is actually Chat GPT-4 right here. So
Built into it, yeah.
I can actually, ask it questions. And once again, I can use my work one. This is only Microsoft. This particular thing is only Microsoft, and this thing is the web-based thing I can do. So I can, make it more precise. This is what we call temperature, and this is GPT-4 actually. So now I can tell it, tell me a story about a king and a queen on a picnic, and it can start doing that, and it'll do this for me. And again, maybe I just need an analogy or a fun story for my intro today or whatever, and it does this sort of thing. And again, this is free, so it would charge you. This is OpenAI basically for free. You get so many hits a day and so on. And here we go. You can see that it's starting to. It's a bad story. So if you need if you need a if you need a story to put your kid to sleep tonight, you can always do that. There we go, honey glazed chicken, because that was real big back in the Middle Ages. Small rabbit hopped over them. Okay, with the little creature eating that's kind of wild. And they sang songs with the little creature. Okay, well there you go.
Nice.
This is off the cuff. That had nothing to do with what we were talking about today, folks. It's just kind of a thing. All right, back to Slide World. And back to you, Reed, for any questions or things like that you might have in the next few minutes.
Yes. So let's see there. See if I can go to page 2. He didn't have any follow-ups to that, but I think just for kicks and giggles, I want to address the question from Alex Powers. So between you and Patrick LeBlanc, who makes the best etouffee?
Oh, yeah,
if I'm pronouncing that right?
Crawfish etouffee, that's going to have to be me, obviously.
What's his
both,
best? If you do crawfish, what does he do?
He might do shrimp or something like that, I would guess.
Okay.
I don't know, he might do crawfish as well. We're both Cajun, or Cajun-ish. So we're both from that area in New Orleans. That he's a little further north, but my people come from that area. So I do crawfish etouffee, coubillon, gumbo, jambalaya. Whatever.
See, like you're just silly me on the point that sometime if we're ever in a similar city where you have the opportunity to cook, I would hope I get a chance to try some of your cooking. Because I love Creole and Cajun food so much. Like give me spicy, flavorful, and delicious. Yeah.
Yeah. There we go. You could ask GPT how to make a good coubillon.
Honestly, like for things around the house, like I mean, it's a better version of Alexa, but. I've actually used it quite a lot for asking for suggestions for cooking recipes, things to do. It's actually been one of between myself and like Kurt Bueller, a few of the other like nerdy D&D people, it's really great for helping you write campaigns and to create items to fill out the story. So there's a lot of fun, as you said, task automation.
That's right.
Little small things to help you with your day, or it's a great assistant for you to come up with ideas.
Awesome. Well, good stuff.
Yeah, and a couple other questions then. So from Mark, he wants to know if about any wins or success stories of implementing Copilot for enterprise within financial services, if you've heard of any.
So specifically for financial services, it's usually in customer support, right? In the customer support area, them writing bots and things like that. That is a very pedantic thing to do, a very common thing to do, but it is very powerful. People get an answer to their question quickly, and they're not like they used to be. Please hold on, and I will look up your account. They're so much faster and better if you do it with a good GPT.
Okay, yeah. I think as the more into customer facing and conversational it moves, it seems to be the more powerful it is.
That's very true.
With a lot of this stuff, and. Oh, actually, one just quick follow-up, and then I'll have one last question. So, follow-up question from Mark. Nothing on the Excel front for data analytics?
Actually, quite a bit. Actually, there's a Copilot for Excel, and there's a whole bunch in there for data analytics. It's just Excel is the tool that can do anything. It is just amazing. Let me just really quick see if I can find a reference while we're talking about the changes that we've made for Copilot there.
The one thing that I love that it's integrated into Power BI. I just hope that I'm sure at some point in the future the SKU requirement will lower the bar on what's required for like the writing the DAX descriptions automatically using Copilot and the query view and
You're
all that
gonna
other
see
stuff. I love
stuff.
it, but yeah.
You're gonna see stuff. Yeah, there's a whole bunch of the Copilot. So one of the things that you can do is get insights. So there's an analyze, and you can do a specific prompt. So show me the sales categories over time, show
Hmm.
total sales for each product. So total sales of advertising for each region last year. Be specific with your questions. So for you, Reed, I've posted in our private chat that link. That's where I'm at right now. But there's a ton in here, and it's just going to keep getting better. It's just going to keep getting better.
And I'll paste that into here. And then last one from you, and actually where you'll be presenting soon. So Data is King had a comment that you'll be at the SQL Saturday in Jacksonville. Looking forward to seeing you there. And then he
Yes.
wanted to know if there's any other events you'll be presenting at that people should be aware of.
Yeah, I just finished a run. It's kind of funny. I uh, blew out my gallbladder right before I had 3 weeks of international travel. And I've just this week, just 2 days ago, I had surgery. So I'm sitting here with
Still
all
recovering.
bandaged up, and yeah, I'm a little messed up right now. But just did normally they're spread throughout the year, but I did SQL Bits in the UK. I did the MVP Summit in Seattle, and I did the Fabric Conference, Microsoft Fabric Conference in Las Vegas. I've got
Same
this
here.
one coming up. Yeah, I've got this one coming up in Jacksonville. We're doing an all-day pre-con, hands-on with everything you just saw, including in Fabric and SQL Server. So that one will be pretty exciting. And then I think I'll be at Live 360 is my next one, which is in Orlando, and I don't remember what date that is. That's the current thing. I've been off for this surgery, so my calendar is not booked. I didn't know when the surgery was going to happen, so I haven't booked as many speaking engagements. Even next Friday is going to be pretty interesting traveling like this.
Well, good luck with it. I just dropped a link to the Jacksonville. What was the other one that you said?
Live
Something
360.
365? Yeah,
Live
Live
360.
360.
I love that event. Really, really cool place too. It's in Orlando, and it's at the Universal Studios. So you bring your family, and they have a blast while you're getting trained. And it's a beautiful facility, and they have everything: development, AI, databases, analytics. It's amazing. It's a great
I
conference.
think this was one of the ones that like a couple of years ago Treb told me I should start applying to because I believe they have fairly good like after event parties and things like
Oh
that
yeah,
too.
oh yeah, yeah, yeah. No, they've got a lot of
Yeah,
stuff.
they throw a lot of money into it.
And you're
So
on the property. You're on Universal Studios. You walk out of the
that's
hotel up the
fun.
walkway to the entrance to Universal Studios with all the food and everything else. It's pretty amazing.
Excellent. I dropped that link in there as well then. But yeah, I'm sure I will also be seeing you at some point in the near future at one of these events. We cross paths on a
Absolutely.
regular basis. And
Absolutely.
final comment, looks like Gaston Cruz is also just hanging out in the chat, and I wanted to say hello as well.
Gaston, good to see you, sir.
But
Fantastic.
this has been fantastic. I will say a couple people just commented on the fact that it's a very fun and you bring a lot of playfulness, certainly to your presentations, some fun analogies, anecdotes, and quips. So it definitely helps to make a presentation go and keep momentum going.
Yeah,
Certainly when you're
especially about
when you're
math.
talking about
Yeah.
when you're talking about technical things. Um,
Yeah.
it's actually one of the reasons that I like Brian Grant. Similarly, like he gets into technical DAX stuff, but on top of talking, the only person who I think talks faster than me. That's a hard accomplishment to achieve. But he similarly has a very playful attitude to his stuff and makes little funny analogies and jokes throughout in which keeps it lighthearted and you're not just
Sure.
sit there with your brain matter melting out of your ears because it's so complex. But
Right.
I want to thank you so much for coming on for this. This has been really fun. I'm sure we'll get plenty of repeat viewers for this, and this certainly is. I think I've done 4 or 5 AI related streams. This is the one that honestly explained it holistically end to end on its
Awesome.
history, and also going into like what does it actually mean, and then how can it be used. So I think it's
Yeah.
a really nice overview of just everything about it and how we got to where we are today with this stuff. So I
Awesome.
appreciate that.
Good stuff. All right, Reed. Thank you for having me on.
Absolutely, yeah. Enjoy the rest of your Friday afternoon, and have a great weekend, and everyone else as well. I'll see you online next week. All right, cheers. Thank you so much for watching. Please consider hitting that like and subscribe button. And if you want to help support this channel, take a look at our channel memberships or our merchandise store for cool swag. And last but not least, please consider sharing this video on your social media platform of choice to help our channel grow. So, until next time.